All right, we are starting parts of Chapter 7, and the first part, section in Chapter 7, 7.1, is about ratios and proportions. And those words might sound familiar to you. Hopefully they do just a little bit. So the objective of the video is to write and simplify ratios, and then to use proportions to solve problems. So maybe you have heard of these words before, but you've forgotten what they mean. A ratio compares two numbers, and you can think of the numbers as quantity of things. So you could do the ratio of boys to girls in the classroom. When I say proportion, that's an equation. So there's an equal sign. And the equation is of two ratios. So for example, I could say that the ratio of A to B, these being numbers, is equal to the ratio of C to D. And so sorry, going back just a little bit, when I say ratio compares two numbers, it compares two numbers by division. And that's kind of important. So for example, you could write it as a fraction. You could write it with a colon. How else can you write it? Or you can write it with the words A to B. Those are the three ways to write ratios. And then when you set two ratios equal to each other, that's called a proportion. Now, when you look at this proportion, there are two things called the means and extremes. And then when I say means, I'm talking about the B and the C. So the means are these bad boys, and the extremes are the A and the D. And the means and extremes are important because when we cross multiply, or the cross products, that's when you're multiplying the means and the means with the means and the extremes with the extremes. So if you cross multiply this ratio, the cross products would be A times D of the extremes together is going to equal the multiplication or the product of the means together. Okay, and I think you guys have done this before. All right, so we're going to use ratios today to solve stuff in geometry. And we'll get to the whole cross products in just a second. So example 2, how can we use ratios? These are important questions. So the ratio of the side lengths of a triangle is 4 to 7 to 5. Oops, I did not want to do that. Okay, and its perimeter is 160 centimeters. What is the length of the shortest side? Okay, so some important information. We have the ratio, we have the perimeter, and then obviously the question is, what is the length of the shortest side? Whenever you see a ratio, you're going to put x's with it. So 4 is going to become 4x, 7 is going to become 7x, and 5 is going to become 5x. And then it talks about perimeter. We know perimeter is just the distance around something. So the distance around this triangle is going to be 160 centimeters. And if you add up all the sides, it should equal 160 centimeters. So that's what you're going to do. You're going to add them up. 4 plus 7 plus 5, I believe, is 16x. And then you're going to divide both sides by 16, and you're going to get x equals 10 centimeters. But we're not done, because then we're going to go back and read the question. What's the length of the shortest side? Well, which side do you think is shorter? The 4x, the 7x, or the 5x? I'm going to guess the 4x because it has the smallest coefficient. So when I plug in x to the 4, I'm going to get that my shortest side is 40 centimeters long. And that's your final answer. Okay. Let's see, number 3 is very similar to number 1. Number 2 I'll do with you, and then you guys will be responsible for 3 and 4. Okay, number 2 says the ratio of angle measures in a triangle is 2 to 5 to 11. What's the measure of each angle? Well, in this one, this is bothering me, sorry. In this one we're talking about angles, and this one we were talking about sides. Perimeter means sides. This one we're talking about angles. Again, with the ratio, we're still going to do the same thing, 2x, 5x, and 11x, but this time it doesn't give us another number. Here it gave us 160. Here it doesn't tell us what other number. But since we're talking about a triangle and we're talking about the angles, we already know that the angle measures always add up to be 180 degrees. So if we add these up, it should equal 180 degrees. So we're going to add the coefficients, and we get 18x equals 180, and wouldn't you know it, x equals 10 degrees. And then we have to, look at the question, what's the measure of each angle? So we plug it in 3 times this time. 2 times 10 will be 20 degrees. 2 times 5 would be 50 degrees. And then that other angle would have to be 110 degrees. And we can check our work by noticing that they all add up to be 180 degrees. Okay, so you're responsible for 3, 4, and then here's one of the reflections. Okay, example 3, cross products property. Again, if we cross multiply, those means the product of the means will equal the product of the extremes. So that's all we're going to do. So for example, in number 5, and it doesn't really matter which way you cross multiply. So I'm going to do 2 times d equals 3 times 6, and then I'm going to solve. 2d equals 18, and then divide, d equals 9, and I'm done. So you can do 6. If you notice, number 7 and number 8 are just a little bit more complex in terms of algebra, but the process is still the same. So I'm going to cross multiply. So this time I have z minus 4 times z minus 4 equals 20 times 5. To multiply these two binomials, you guys did this in algebra. You could use FOIL, you could use the box. I'm going to distribute. So I'm going to go z times z is z squared. So I did 1z times 1z. Then I'm going to go z times negative 4. That's negative 4z. And now I can't multiply this z by anything else. So I'm going to move on to the next term. So negative 4 times z is negative 4z. And then this negative 4 times this negative 4 will make a positive 16. And then 20 times 5 is 100. Okay, so we're going to practice multiplying binomials again in class. When you combine like terms, now you have this negative 4z and this negative 4z. So that's negative 8z. So now I have z squared minus 8z plus 16 equals 100. Then I'm going to subtract this 100 over. Z squared minus 8z minus 84 equals 0. And then we're not done yet. I want you to stop right here, and then we'll continue factoring this in class. I'll show you how to do it in class. I want you to do the same thing for number 8. It's important that you stop when it equals 0. Move everything over to one side and set it equal to 0. I'm going to be checking tomorrow to see that you've done number 8. Okay, last one. Properties of proportions. Basically, there's lots of ways you guys can multiply the numbers or rewrite the proportions, and they're all going to be equivalent or equal to each other. So for example, if I write my proportion this way or this way, notice all I did from here to here was just flip everything. So instead of a over b, I did b over a. Instead of c over d, I did d over c. And notice in this one, all I did was I wrote a and c, the tops, equals the bottoms. So we're going to talk about how you can rewrite proportions in class, and just look at the correct answer. Okay, last one we're going to do. Given that 18c equals 24d, find the ratio of d to c in simplest form. Let's see. So we want it to look like a d over c in the end. So I'm going to take this, and I'm going to try to get d on the top. Oops, I don't remember what this is. I'm going to try to get D on top and C on the bottom. That's what I want it to look like. Okay, so I already have D. That means I need to move the C over. All right, so I'm going to divide both sides by C. And so now I have 18 equals 24D over C. But I don't want this 24, right? I just want D over C. So that means I'm going to divide both sides by 24. So now I have d over c, and I know d over c equals 18 over 24. All you have to do now is reduce. I think they both divide by 6. So 18 divided by 6 is 3, and 24 divided by 6 is 4. So my final answer is the ratio of d to c is 3 over 4. See if you can't do number 10, and then we'll work on the rest of them tomorrow. Oh, fun fact of the video. Where is it? People in the United States eat more bananas than apples and oranges combined. Yay! For ratios and apples and oranges.